So you've started playing with large language models, and you're probably thinking it's all about writing clever prompts, right? Well, today we're going to pull back the curtain and look at what it really takes to go from a simple chatbot to a robust production-grade AI application. We're talking about the 8 essential skills you're going to need. Let's jump in.
And this right here is the absolute core of it. Moving past the playground phase means you have to start treating LLM development like a serious engineering discipline. Because let's be real, production-ready systems demand so much more, a way deeper understanding of how these things are actually built, deployed, and tweaked for the real world.
To get a handle on all this, we're going to follow a kind of developer's journey, broken down into 4 key stages of mastery. Think of this as our roadmap for today. We'll start with just talking to a model, and by the end, we'll see how to make it run like a well-oiled machine at a massive scale.
Okay, let's dive into stage 1, mastering the conversation. Before you can build anything really complex, you have to get this fundamental interaction absolutely perfect. It is the bedrock for everything else we're going to talk about. This is where everybody starts, but there's a huge difference between asking a simple question and true prompt engineering. This is the skill of designing your instructions with such precision that you squeeze out all the ambiguity. The goal? To get predictable, reliable, and consistent results from the model every single time. And you can see here, this isn't just about creative writing or trial and error. It's a systematic process. You're using established patterns like chain of thought prompting to help the model reason. You're giving it examples to guide its answers. You are iterating on it just like any other piece of code. But, a perfect prompt is useless if the model doesn't have the information it needs. And that brings us to our next skill, context engineering. See, an LLM only knows what's in its training data and what you tell it right now. This skill is all about dynamically feeding it the right external information, say from a document or a database, at the exact moment it needs it. And this is absolutely critical. It gives the model fresh, up-to-the-minute knowledge. But it's a really tricky balancing act. You've got to provide enough context for a good answer, but not so much that you're wasting expensive tokens. And you have to avoid major pitfalls like context collapse, which is basically when the model gets so overwhelmed with information that it just loses the plot. All right, let's level up to stage 2. We've mastered the art of conversation. Now it's time to actually change how the model thinks and what it knows. We're literally going from prompting the model to customizing its mind. The first big way we do this is with fine-tuning. Here's a good way to think about it. Imagine you've got a brilliant generalist, like a PhD, who knows a little about everything. Fine-tuning is like sending them to law school. You're taking that base model and training it on your own specialized data to teach it a new skill, or a specific rating style, or some other unique behavior. It is a delicate process, though. You're using really efficient methods like LoRa to reduce costs, but honestly, the real heavy lifting is in curating your data set. All the while, you have to be super careful about overfitting. That's when the model just memorizes your examples instead of learning the underlying skill. Now, alongside fine-tuning, you have RAG, which stands for Retrieval Augmented Generation. And this is an absolute game changer for accuracy. Instead of trying to teach the model a new skill, you're essentially giving it access to a massive external library, like a vector database, that it can consult in real time to find facts and, most importantly, reduce those infamous hallucinations. So building a good RAG system means you're engineering a really smart retrieval pipeline. You're thinking about how to chunk and index your data, and then you're using clever prompts to perfectly blend those retrieved facts with the user's original question. The whole goal here is just maximum accuracy. So if you're ever confused, here's a super simple way to remember the difference. Fine-tuning teaches the model how to do something new, like adopt a personality. RAG gives the model what it needs to know. New facts and knowledge it can access whenever it wants. One is skill, the other is knowledge. Okay, we've got this powerful, customized model. Now what? It's time for stage 3, turning this thing into a functional application that can actually, do stuff in the real world. This is where the model gets a job. And that job is often performed by something called an agent. This is the big leap from a simple Q&A bot to something truly autonomous. An agent is an LLM that can create a multi-step plan, use tools like APIs, and interact with its environment, all to accomplish a complex goal without a human holding its hand the whole way. So how does an agent actually think? Well, it runs in this powerful loop. It gets a goal, it chooses a tool, maybe an API call, it uses it and observes the result,
Then it reevaluates. Did that work? What do I do next? And this loop just keeps going until the goal is finally achieved. Of course, none of this matters if it only works on your laptop, right? Deployment is that absolutely crucial skill of packaging your model, your agent, your whole system into a scalable, reliable API that can serve thousands, maybe even millions of users without breaking a sweat. And let me tell you, deployment comes with some serious engineering headaches. You have to worry about performance under heavy traffic, you have to build security guardrails to prevent people from misusing it, and, this is a big one, you have to monitor the cost of every single request to make sure you don't blow your budget. We are on the home stretch now. Stage 4 is all about taking that deployed application and turning it into a truly professional, high-performance system. This is the final mile of our journey. And this starts with optimization. LLMs are massive. They're expensive to run, so we use techniques like quantization, which uses less precise numbers to save space, or pruning, which literally snips away unnecessary parts of the model. It's all about making the model smaller, faster, and cheaper to run. It's really all about finding that perfect sweet spot. You're constantly trying to lower your costs and your hardware needs, but you have to benchmark every change to see the trade-offs. The goal is always maximum efficiency, but without breaking the core features that your users rely on. And finally, our 8th skill, LLM observability. The best way to think about this is like giving your application a central nervous system. It's about putting in all the tools, the logs, the traces, the dashboards that let you see exactly what's happening inside your system as it's happening. And for a production app, this is completely non-negotiable. You can't fix what you can't see. Observability lets you track costs, spot performance bottlenecks, and see how real users are actually talking to your model. That data is pure gold. It's the fuel for every future improvement you'll make. So there you have it. We've gone on the full developer's journey, from writing a single prompt all the way to a fully optimized production-grade application. These 8 skills are really the pillars of modern AI engineering. But this field is moving so fast, which brings us to one final question for you. What skills would you add to this list? Have a think about it.